Right at this moment, while you are listening to these lines, something is happening that almost no one on Earth knows about. A machine the size of a small bus has been dead for 9 years. It burned up like a meteor in the atmosphere of Saturn on a morning in 2017. It turned to dust and vanished from the map of the universe, but the final data it sent back is still being read for the first time in laboratories around the world. This is not a new spacecraft. It was built before Google existed, before smartphones existed, before most of the scientists now studying its data had even graduated from college. And this machine that has been dead for 9 years is right now forcing humanity to rewrite 6 different textbook chapters just in the past 18 months. The researchers reading its data are not using words like interesting or surprising. They are using words like extraordinary, inexplicable, and we were wrong. This is the story of Cassini, and this is the part the headlines do not tell you. There is a day locked into the calendar this year that will mark exactly 9 years since the moment a group of engineers in California sat down together and deliberately killed the child they had spent 2 decades creating and raising. Stay with me because by the time this story ends, you will never look at Saturn the same way again. Subscribe right now if you want to hear more stories like this because we are only just beginning. Let us go back to the beginning. A rocket lifted off from Cape Canaveral Air Force Station in Florida carrying a spacecraft named Cassini. This machine was the size of a small bus, weighed nearly 6 tons, and was not the project of a single nation. It was the result of 17 years of collaboration between NASA, the European Space Agency, and the Italian Space Agency. Nearly 5,000 scientists from 18 countries worked together to build it. It carried a smaller probe named Huygens, designed by Europe to land on one of Saturn's moons. The mission assigned was simple and modest. Fly 7 years to Saturn, enter orbit, take some pictures, measure the magnetic field, observe the rings for 4 years, then run out of fuel and fall silent. NASA planned to celebrate the end of the mission around 2008. It would have been a successful trip, a beautiful postcard from the ringed planet, then silence. What actually happened is one of the most extraordinary things in the history of science, and most people have no idea how extraordinary it was. Cassini did not fall silent. On the 1st of July 2004, it entered orbit around Saturn and became the first spacecraft in history to do so. 7 months later, on the 14th of January 2005, the Huygens probe separated from Cassini and landed on the surface of Titan, Saturn's largest moon. That was the first and only soft landing by humans in the outer solar system. Never before and never since have we touched the surface of a world so far away. The European team thought Huygens would splash down into an ocean. In reality, it landed on what appeared to be a dry riverbed. But the liquid that had once flowed there was not water. It was methane. And Cassini kept going. Over the next 13 years, it completely transformed humanity's understanding of the Saturn system. In 2006, it caught a small moon named Enceladus, spraying jets of gas and ice into space, something no previous model had predicted. It discovered liquid methane lakes on the surface of Titan. It found 6 new moons of Saturn. It watched the 4 seasons of Saturn change in real time. The final mission numbers are staggering. 4.9 billion miles traveled, 294 orbits of Saturn, 450,000 photographs, 635 gigabytes of scientific data, in total 20 years of flight in space and 13 years around Saturn. NASA extended the mission twice. The original 4 years became 9. 9 became 13. Cassini never stopped discovering. But by 2016, it was nearly out of fuel. And the team at the Jet Propulsion Laboratory began facing a decision no one wanted to make. The problem was not how to make Cassini die. The problem was how to make it die without killing something else, something it had itself discovered. Picture the situation. Cassini had been orbiting Saturn for 12 years. The hydrazine fuel, used to adjust orbit and orientation, was nearly gone. When the fuel ran out, the engineers would lose the ability to control the spacecraft. It would drift freely through space, and over the course of a few hundred years, its random orbit could slam into one of Saturn's moons. If it were any other moon, the incident would just be an unnoticed collision. But Cassini had discovered something that changed everything. Enceladus, the small moon it had photographed spraying water jets into the air in 2006, had a subsurface ocean beneath its icy crust. Liquid water, warm, containing organic molecules, capable, at least in theory, of supporting life. And here is the worrying part. Cassini carried Earth bacteria stuck to its metal surfaces, bacteria that may have survived 20 years of space radiation, protected in tiny crevices. If Cassini drifted freely and eventually crashed into Enceladus, it could deliver Earth bacteria into that moon's ocean. Any future search for life on Enceladus would be permanently contaminated. We would never know whether the life we found there was truly native or simply what we ourselves had brought. So the JPL team made the decision no science team ever wants to make. They would kill Cassini, deliberately, on a schedule. And they would turn that death into one of the greatest scientific contributions of the entire mission. The plan was named the Grand Finale. The goal was to use Cassini's final months to measure things no previous spacecraft could measure: a detailed map of Saturn's gravitational field, the internal structure of the planet, the precise mass of the rings, and samples of the ice particles being pulled from the rings into the atmosphere. The timeline had 3 critical stages. On the 30th of November 2016, Cassini began 20 high orbits over Saturn's north pole, diving near the outer edge of the F-ring. On the 22nd of April 2017, Cassini flew past Titan for the final time, using the gravity of that giant moon to bend its orbit toward the gap between Saturn and the rings. 4 days later, on the 26th of April, Cassini made its first dive through that gap. The gap was only 2,000 kilometers wide, narrower than the distance from New York to Denver. No one knew what that region contained. Models predicted it might hold dust particles and debris dense enough to destroy the spacecraft on impact. Cassini went anyway. It rotated and used its 4-meter-wide radio antenna as a shield against the particles that would hit it. The suicide schedule was locked for the 15th of September 2017. It had been signed off. There was no turning back. But on the 26th of April 2017, when Cassini made its first dive through the gap, what it found was not what the engineers had feared. Nothing. No dense dust particles, no debris, no impacts. Cassini's radio and plasma instruments on that first dive heard only silence. The region between Saturn and the rings, which every model had predicted would be thick with particles, was in reality almost empty. Earl Mays, Cassini project manager at JPL, stood before reporters and named it the Big Empty. Cassini could lower its shield. The remaining 21 dives would be safe. But that was only the surface story. During 6 of the 22 dives, a direct radio link between Cassini and Earth was maintained. As the spacecraft flew through the gap, its signal was slightly deflected by Saturn's gravity on one side and the ring's gravity on the other. By measuring that deflection to an accuracy of parts per billion of a second, a research team at Sapienza University in Rome, led by Luciano Yes, could separate the mass of the planet from the mass of the rings. The results were not published until 2019, nearly 2 years after Cassini had died. But when they appeared in the journal Science, they forced every astronomy textbook to be rewritten. Saturn's rings are only 10 to 100 million years old. Saturn formed about 4,500 million years ago, but its rings appeared only recently. Dinosaurs were walking on Earth when Saturn had no rings. And here's the part that makes the story even more unsettling. The rings are not only new, they are also disappearing. Ring material is being pulled down into Saturn's atmosphere by gravity and magnetic fields. In about 100 million years, the rings will be completely gone. That means humanity appeared at exactly the right moment, in a cosmic blink of an eye. If we had arrived 200 million years later, the most famous symbol of the solar system would no longer exist. Now pause and reflect on that for a moment, because it does not just tell us about Saturn. If Saturn's rings can appear and disappear on a timescale of 100 million years, then the model we have of the stability of planetary systems is fundamentally wrong. Jupiter's faint rings, can we be sure they are as old as the planet? The rings of Uranus and Neptune, do they have limited lifespans? And there is an even more uncomfortable question. If Saturn's rings formed from a shattered moon or a crushed comet, then what triggered that event only 100 million years ago? And what guarantees that kind of event could not happen closer to us? We tend to think of the solar system as a clockwork machine that has been calibrated since the universe was young, but what Cassini is telling us is that picture is not correct. The solar system is not a clockwork machine. It is a dynamic system. It has births and deaths, and just as your mind is trying to absorb that we need to go back to 2017, because what happened in the JPL control room on the morning of the 15th of September has never been fully told. Picture the control room. Dawn on the 15th of September 2017, JPL, Pasadena, California. Outside it was still dark. Inside the Cassini team had gathered since 4 in the morning. Many of them had spent more than 20 years of their lives working on this mission. Some had signed off on instrument designs in the 90s when their children had not yet been born. Now their children had graduated from college. And the machine they had spent their entire careers building and nurturing was plunging toward its own death at a planet 1 billion kilometers from Earth. Cassini was moving at 123,000 kilometers per hour. This was not an orbit, not a flyby. This was a straight line down into the center of the planet. In about 45 minutes, the spacecraft would begin to touch the first molecules of Saturn's upper atmosphere. In the 2 minutes after that, it would break apart. But before that, there was work to do. At an altitude of 1,900 kilometers above Saturn's cloud tops, Cassini's small thrusters began firing continuously to keep the main antenna pointed toward Earth. This was a hopeless fight against atmospheric drag. The atmosphere was pushing the spacecraft to tumble. The thrusters were fighting back. As long as they won that fight, the signal would keep arriving. In that moment, Cassini was transmitting data on plasma density in Saturn's atmosphere, the chemical composition of the upper clouds, the strength and direction of the magnetic field at depths never measured before. Every second that passed, the spacecraft moved deeper into an environment no human instrument had ever reached. After 1 minute, the thrusters were operating at maximum power. Only 10 seconds later, they were overwhelmed. The spacecraft began to tumble out of control. Contact with Earth was lost. The onboard computer tried to switch to safe mode to correct itself. About 1 minute after that, the spacecraft completely broke apart and burned up in Saturn's atmosphere. Earl Mays stood in the middle of the room wearing headphones, eyes fixed on the screen showing the strength of the signal. In his hand was a piece of paper with a single sentence written on it, 7:55 in the morning Eastern Time. The signal path from Saturn to Earth took 90 minutes because of the distance. That meant when Earl Mays and his team were watching the signal, Cassini had actually been destroyed 90 minutes earlier. They were watching a ghost, the ghost of something that had died while they were drinking coffee. But the ghost was still speaking. Data was still arriving. Cassini was transmitting scientific data right up to the final moment, deeper into Saturn than any spacecraft had ever gone, sending back measurements that no planetary weather model on Earth had ever possessed. Then, at exactly the predicted moment, the signal graph on the screen began to tremble. The strength dropped, then dropped again, then disappeared. Earl Mays leaned into the microphone. His voice shook. He read the prepared sentence. The signal from the spacecraft has been lost, and in the next 45 seconds, the spacecraft will be as well. The room went silent. Then the applause began slowly and broke into something else. Some people cried, some hugged each other, some stood still, staring at the black screen. But this is what no one outside that room truly understood in that moment. The JPL team had not killed Cassini because they had to. They had killed it because Cassini itself had found the reason it had to be killed. If Cassini had not discovered what it discovered at Enceladus in 2005, there would have been no need to destroy it. Cassini could have been left to drift freely. It could have lived for many more decades in an increasingly erratic orbit until it finally fell onto one of the moons, and no one would have cared. But Cassini had discovered, and by discovering it, had written its own death sentence. The JPL team had no choice. They had to kill Cassini because Cassini had been too successful. It had found something worth protecting from itself. That is a kind of pain engineers do not describe in interviews, but it sits at the center of the entire story. The machine died because the machine was magnificent. But the story of the 22 dives does not end with the emptiness. While Cassini was flying through the gap time after time, something else was happening that no one talked about in the press. Before the grand finale, no one knew what Saturn looked like on the inside. We knew it was a gas giant. We knew it had a core, we had theoretical models, but we had no direct measurements. What the 6 radio science dives revealed rewrote the book. Saturn's core is not a solid, dense mass. It is far more diffuse and fuzzy than the models predicted. The core mass between 15 and 18 times the mass of Earth, that was confirmed. But Saturn's winds, the famous storms racing around the planet at thousands of kilometers per hour, do not sit only in the surface atmosphere. They extend down 9,000 kilometers into the interior of the planet, 3 times deeper than Jupiter's winds, almost to the core. Planetary researchers are now rebuilding the entire theoretical framework for gas giant worlds, including exoplanets thousands of light years away that we have never approached. Then there was a problem that sounded simple, which Cassini spent 13 years solving. How long is a day on Saturn? It sounds easy, but there are no landmarks on a gas giant for you to track. Clouds move at different speeds from the core. The rings rotate at different rates depending on their distance. Before Cassini, the best estimate from Voyager data was 10 hours, 39 minutes, 23 seconds. But over the 13 years, Cassini observed the number drifted by about 1% each year, as if the planet itself were changing its rotation rate. That, of course, is impossible. In the end, the scientists solved the problem another way. They measured the ripples that Saturn's gravity creates in its rings. The final answer is 10 hours, 33 minutes, 38 seconds. A day on the most iconic planet in the solar system. We only just learned the exact length thanks to a machine that is dead. And that is only the mysteries that have been solved. There are many more that have not. Saturn's magnetic field is 580 times stronger than Earth's, but its magnetic pole aligns with its rotation axis to an accuracy of less than 0.1 degree. According to the currently accepted dynamo theory, this is impossible. No other planet in the solar system behaves this way. Saturn emits twice as much heat as it receives from the sun. No one knows exactly why. Saturn's auroras do not depend on the solar wind the way Earth's auroras do. They originate from inside the planet, not from the sun. The hexagonal storm at the North Pole is 29,000 kilometers across, large enough to fit 2 Earths inside. It does not move, does not change, and no theory explains why a storm can maintain a perfect 6-sided shape for decades. Many models are being tested, none fit completely. All of these questions come from the data of the 22 dives plus 13 years of observations by an aging machine that dove through a gap no one had ever seen before, measuring its gravity to parts per billion accuracy, then continued flying to its scheduled death. Cassini died while still discovering, and that is the kind of death a scientific machine can dream of having. Now let us talk about what is happening right now, because this is the part of the story the news has not told you. Cassini died in 2017. The media moved on to other stories. The Cassini story seemed closed, but inside NASA's planetary data system, terabits of raw data are still waiting to be read. Most of the datasets, according to one scientist in Berlin, have not been carefully examined. Then 2024 happened, and after that, the 18 months that left planetary astronomers stunned. February 2024. Valery Laney at the Paris Observatory published in Nature. He reread Cassini's orbital data on Mimas, the small moon long thought to be geologically dead for decades. In the way Mimas wobbles in its orbit, there are traces of liquid beneath the crust. Beneath Mimas, there is a global ocean 20 to 30 kilometers deep, perhaps formed only 25 million years ago. The machine had been dead 7 years, but it had just found another ocean. July 2024. Cornell University published a new analysis of the methane seas on Titan. There is wind, there are waves, there is motion that no previous model had predicted. October 2025, Nozer Khawaja in Berlin published in Nature Astronomy. He reread the cosmic dust data from Enceladus and found new complex organic molecules, esters, ethers, alkenes, evidence that Enceladus's ocean is performing chemistry that could lead to life. December 2025, Nature published a study led by JPL. Titan may not have a global subsurface ocean as believed since 2008. One of Cassini's most widely credited discoveries had just been overturned by Cassini's own data. February 2026. The Paris Group published. Enceladus generates giant magnetic waves that stretch across the entire Saturn system. Cassini had recorded this for 13 years and no one had noticed. March 2026. 2 French researchers published in Icarus and said something no one wanted to hear. Perhaps the ring age discovery from 2019 was wrong, but we will come back to that. 6 papers, 18 months. 1 dead machine. Nicholas Altobelli Cassini, project scientist for the European Space Agency, said when interviewed, "It is wonderful to see new discoveries emerging from Cassini data nearly 2 decades after collection. In other words, the machine has been dead 9 years already. And it is still speaking. And now we arrive at the day locked into the calendar, the 15th of September 2026. Exactly 9 years since Cassini died. In about 3.5 months from when you hear these lines, there will be no ceremony. There will be no official remembrance. NASA might post a single tweet. A few journalists might write anniversary pieces, but most of the world will not remember. 9 years is long enough for a dead machine to become a historical footnote. But right now, as you hear this, things are happening that the press will not report. In labs across Europe and America, the researchers whose names you just heard are continuing their work. Someone is processing unread cosmic dust. Someone is rereading the orbits of other moons, perhaps finding more subsurface oceans. At JPL, scientists are maintaining the archive, checking the integrity of the tapes, migrating data to new storage media. You can do this yourself, right now. Open your browser, go to NASA's Open Data page. Type Cassini into the search box. Hundreds of datasets will appear. Tiger 1, NEGR 6, Sagar 7, SROC 25, code names for the measurements Cassini made, 63,022 observations scheduled across the entire Saturn tour. Each file is a story that may not yet have been told. The machine is dead, but its calendar still holds. Voyager has the golden record. Cassini has something else. Not gold-plated copper, not carrying music and laughter, not designed to speak to aliens. Cassini has a data archive. 5 terabits of information stored in the PDS, NASA's permanent storage system, copied 3 times on different drives at different facilities, restructured and moved to new storage media roughly every 10 years. In Cassini's final mission report, a 1,759-page document that can be downloaded for free, there is a description of every instrument, every target, every major result of the 13 years of observation. That is the instruction manual for the future. Voyager's golden record may survive 1 billion years as it drifts silently among the stars, but it speaks in a simple language, sounds images, signs for an entirely different kind of observer. Cassini's data archive speaks a different language. It speaks to future scientists. It does not teach them who we were. It teaches them what we saw. The golden record has never been read by anyone. No one knows when it will be read or if it will be read at all. Cassini's archive has already formed the foundation for more than 4,000 scientific papers. And that number is still rising. This data archive will outlast JPL. It may outlast NASA as an organization. Somewhere in the distant future, a researcher not yet born today will sit in front of a screen and download a Cassini data file with questions we have not yet thought of. And they may find something we missed. Recall the young ring discovery. ES and his team in Rome, 2019, 100 million years. Textbooks updated, high school students retaught, Wikipedia revised, the story settled until March 2026. Two French researchers, Gregorio Ricerchi and Aurélien Crida, published in the journal Icarus. They re-examined the very reasoning behind ES's discovery, and they said something the astronomy community did not want to hear. Perhaps we were wrong. Their argument is subtle. ES calculated the age of the rings by measuring mass and assuming cosmic dust is accumulating on the rings at a known rate. If the rings are new, they are still clean. If they are old, they would be dirty. Saturn's rings are clean, therefore they are new. But Ricerchi and Crida pointed out a loophole. If dust is also being pushed out of the rings, by collisions, by scattering, by falling into Saturn, then the age clock is not that simple. The rings could be young, or they could be as old as the solar system itself, but continuously cleaned. Cassini's data cannot distinguish between the two scenarios. In other words, the machine has been dead 9 years, but the very data it sent back is contradicting itself, depending on who is reading it. This is what makes the Cassini story different from Voyager. Voyager is still alive. Every day it sends new data, but Cassini is dead. The data is closed. And yet 9 years later, the way we read that data is still changing. Established discoveries are being overturned. The machine is no longer speaking, but we still have not understood what it said. Perhaps there is a kind of science that only dead machines can do, and to settle the ring age question once and for all, the scientific community needs new data. Cassini cannot provide more. That means a new mission to Saturn is required, but there is no plan for such a mission. Dragonfly, NASA's upcoming mission to the Saturn system, will launch at the end of this decade and arrive at Titan in 2034. But Dragonfly is a drone aircraft designed to fly around Titan's surface. It has no capability to measure the rings. It is not designed to visit Enceladus or Mimas. NASA's Enceladus Orbilander has been proposed, but not yet funded. The European Space Agency is studying an Enceladus mission as part of its long-term Voyage 2050 program. China and India have announced no plans for Saturn. Even in the most optimistic case, the next mission will not reach the Saturn system before 2040. Cassini will have been dead 23 years when the next spacecraft arrives. In those 2 decades, Cassini remains the sole source of direct Saturn data. Any question we ask about Saturn in that time, about the rings, about the moons, about the atmosphere, about the magnetic field, will be answered from data a dead machine already sent back. The dead machine is the only teacher we have left, but a second kind of silence is coming. And it is not the silence of the machine. Ed Stone, project scientist of Voyager for decades, died in 2022. Torrance Johnson, one of the lead scientists of the Cassini imaging team, died in 2023. Many of the original Cassini team members, those who signed off on instrument designs in the 90s, those who calibrated the cameras during the 2-year cruise to Saturn, are now in their 70s and 80s. Linda Spilker, currently Cassini project scientist and one of the people still actively publishing research from Cassini data, is past 60. She will retire in the next decade. The youngest engineer who ever worked directly on Cassini hardware is now 45. When they are gone, who will read the data? Today's PhD students can download any Cassini file from the PDS, but they do not have institutional memory. They do not know why the cosmic dust instrument behaves differently at high impact speeds versus low speeds. They do not know which team argued about how to calibrate the radio data in 2008. They do not know which datasets are fully reliable and which have anomalies you must be careful with. Soft knowledge, the kind not written in documents, is dying along with the people who carry it. The machine has been dead 9 years. The people who created it are dying. Somewhere in the future, perhaps 2050, perhaps 2100, a researcher will sit in front of a Cassini data file and have no one to ask. The documentation will be there. The manuals will be there. But the people who measured, calibrated, understood, they will be gone. The data will survive. But the people who could interpret it with full context will not. This is what I want you to take away from all of this. Because there is a truth sitting at the center of this story that is easy to miss when you focus on the discoveries and the machine and the researchers. Right now, in 2026, the only complete Saturn dataset humanity possesses was collected by a machine that has been dead 9 years. We have built things more expensive than Cassini. The James Webb Space Telescope photographs Saturn every year. Hubble has tracked the planet for decades. NASA's Europa Clipper and the European Space Agency's JUICE are on their way to Jupiter's moons with far more modern technology than Cassini, but none of them have what Cassini had. None of them stayed long enough. None of them collected 5 terabits of direct observational data. None of them dove 22 times through the gap between the planet and the rings to measure the internal structure. There are questions about a planetary system that can only be answered from inside that system. Not from ground-based telescopes, not from satellites in Earth orbit, not from computer simulations, only from a machine that went, stayed measured everything it could for 13 years, and finally died because of its own success. We have exactly one such data set. The machine has been dead 9 years already. The people who created it are aging, and the data is still being read for the first time. The question is not how many secrets Saturn holds, the question is whether anyone is still reading them. Because when the answer becomes no, the secrets will still be there, but they will no longer be spoken, at least not for a generation. If this kind of story is what you came here to hear, subscribe right now and turn on notifications, because next time we will go deeper into what dead machines can still teach us. Leave a comment with what surprised you most, and share it with someone who needs to hear it. This story deserves more than the silence it is receiving.